Hi, everyone. Thank you so much for joining this session today. My name is Jessica Locke, and today we're here to talk about how to harness the power of crowdsourcing using Amazon Mechanical Turk. I lead product management at Mechanical Turk, and today I actually have the privilege of being joined by two of my customers, Keisha Phillips and Jeffrey Finchel. They're going to actually come and talk about how they use Mechanical Turk to you. Again, really appreciate you being here. This is lunchtime, so I understand that some of you might be hungry, so thank you again. So here's what we're going to cover today. So first, we're going to do a quick introduction to what is crowdsourcing. I'm going to provide an overview of Amazon Mechanical Turk. We're going to talk a lot about how customers are using Mechanical Turk, and you're going to hear from Keisha and Jeffrey. And then finally, we're going to talk about how to get started. So first, what is crowdsourcing? Well, you can think about crowdsourcing as taking a very large problem and breaking it down into small pieces. That way, you can have many, many individuals who can contribute to the solution, and you can solve problems at scale that wasn't possible before. And you probably are familiar with a couple common examples of crowdsourcing. My favorite is Wikipedia. Wikipedia is, of course, the internet's encyclopedia. There are millions of articles being updated constantly in multiple languages. And the reason why Wikipedia works so well and is so powerful is because rather than relying on a small, centralized group of experts, it relies on the collective knowledge of the internet. It's really cool. What also makes it really cool is that it actually highlights the notion of the wisdom of the crowd. I don't know if you guys are familiar with this game show called Who Wants to Be a Millionaire? It's a quiz show, right? And an individual contestant will answer trivia questions. And when they get stuck, they can phone a friend, which is an individual that they designated earlier, or they can poll the audience. Guess what? The friend is actually only right about 65% of the time, whereas the audience is right more than 91% of the time. So it really just shows how important and how powerful the wisdom of the crowd is. So what is Amazon Mechanical Turk, and what does it have to do with crowdsourcing? Well, before we get into that, I'm going to tell you about why the need for Mechanical Turk came about. And it's because we came across some pretty big problems that could not be easily solved with computers. Let me show you what I mean. So, quick test. What do you guys see? It's a dog. Yep, that's what we see. Here's what a computer sees. It thinks it's a bull, maybe. Here's another one. This is a sheepdog, right? A computer thinks that it might be a hippie or something like that. Chihuahua or blueberry muffin. Shar-Pei or bath towel. You get the idea. Guess what? Computer vision is really hard. But for people like us, we can actually tell the difference really easily where a computer might not be able to do this. And this is a real-life problem, right? Let's go into another real-life business problem that we actually ran into as well. So in the early 2000s at Amazon, we had a massive problem with organizing our product catalog. We had millions of products to categorize, hundreds of thousands of third-party sellers who were submitting product information all the time. And what you ended up having is duplicates information for the same product, as well as missing or incorrect information. Here's some examples. Oh, and of course, that resulted in a very confusing shopping experience for customers. Here's an example. Are these two products the same? Well, it probably took you like 1 second to figure out that, yes, they are the same products. Even though it's a different image, different description, you can see that very quickly. What is the primary color of this product, of this dress? If you ask me, I would say, yeah, it's a black dress. It's on a black background. But when you look at all the pixels and colors on that actual product, a computer actually might come up with a different answer. So what all this demonstrates is that just using kind of the data alone, it's actually not that easy to automate some of these solutions to these problems. And that's how we came about kind of the insight behind Mechanical Turk. It turns out that humans are still better than the most powerful machines at doing some cognitive tasks, such as identifying objects in photographs. And what we ended up building was a service called Amazon Mechanical Turk. And what we like to say is that Amazon Mechanical Turk provides access to human intelligence at scale via an API. So what that gives customers is an ability to access an on-demand elastic crowd, and they only pay for what they use. Sounds familiar, right? Very similar to other AWS services. So let me tell you a little bit about how the service works. So at the core of it, we operate this online crowdsourcing marketplace. On one side of the marketplace, we have workers. These are individuals that are available to complete tasks to earn money. And we have people who want to apply a few minutes of their time or a few hours of their time. On the other side of the marketplace, we have requesters, customers we call requesters. And these are folks that have business problems, for example, the Amazon catalog problem that I mentioned earlier. And then what they do is that they can actually publish tasks into the marketplace to be completed by many individual humans. And these workers can apply their intelligence, their judgment in completing these tasks. Let's cover some key concepts. So as I said earlier, crowdsourcing is about taking a really big problem and breaking it down into discrete pieces. So you can imagine something like a catalog where you have millions of rows of data, and each individual task could be an individual product. And that's kind of the lowest unit of work in Mechanical Turk, and we call that human intelligence task, or a HIT for short. For a given task or a HIT, you can actually have multiple workers complete the same HIT. And for that, we call it an assignment. So a HIT can have multiple assignments. In this case, there's 3 assignments per HIT. And what that gives you is that it gives you a little bit more redundancy around, if you ask many people and they come up with the same answer, you get a lot more confidence in terms of whether that's the right answer. We have a concept called question-answer data. And you can think of that as a way to describe the task interface or the worker UI. This is what the worker sees when they're completing a task. We have a feature called external question. And this really gives customers a lot of flexibility, essentially using anything you can do with HTML, CSS, and JavaScript to build the right task interface for their need. We already talked about workers. These are individuals that are working on these tasks. And then we have a concept of qualifications. So what qualification allows requesters to do is to segment workers into groups with certain characteristics so that they can target the right tasks to the right workers. So here's an example of a task. So you're looking at an image, which is an image of a document, and it's asking the worker to enter the text that's in the oval, highlighted in the oval. And on the left-hand side, it's a little bit of a snippet sample code. You can probably tell that it has a title, description of the task, and it has the number of assignments, so how many workers you want to complete assignment. How long will the task be available for any workers to do? And then once the worker accepts the task, how long do they have before completing the task? And workers will see what's on the left-hand side, and they'll complete a task on the worker UI. And then the answers come back, and requesters can retrieve them programmatically. If you're not an API user, you're not a developer, that's OK, because the ability to publish tasks and retrieve results are also available in our requester UI. So you can specify the same parameters there as well. And customers usually publish tasks in a couple of different ways. One is in batch mode. So this works really well when you have a data set. So the catalog example is a good one, where every day you're getting a feed from all your sellers about new product information, and perhaps every night you want to actually process that information and perhaps dedupe products as well as fixing incorrect information. And you can do this, again, using our UI or via API. And you can track progress and see results come in as they complete. Another way of publishing tasks is an event-driven way. So this works really well when you want to integrate Mechanical Turk into your business workflow. You would use our API to trigger tasks based on an event. So for example, if you're using the Amazon.com mobile shopping app, there's a way where you can actually take a picture of a product and search based on a picture. And a lot of times, it just works automatically. You find the product. But there are times where the algorithm cannot find the product. And what happens then behind the scenes is that actually there's a task that's being kicked off into Mechanical Turk in your real time so that workers can actually, you can use human workers to find that product using the image. And you can get notifications when tasks complete, so then you can move on to the next step of your workflow. So when you get an answer back from a worker, you can actually process it and actually send it back to the customer. Hey, we found your product. So we talked a little bit about what is the requester experience like. Now let's talk a little bit about what workers experience. So workers can go to worker.mturk.com. They sign up to become a worker. And from there, they can search and browse for a list of tasks they want to work on. And they can spend a few minutes or a few hours, it's really up to them, and they can work on tasks that they find interesting. So who does work on Mechanical Turk? Well, we have over 500,000 active workers, and they're really worldwide. They come from more than 190 countries. And because of this, what you end up having is this 24/7 global workforce. So where you're publishing tasks at midnight, your time, or some other time zone, there's always someone doing work on Mechanical Turk. And that makes it incredibly flexible and scalable. We also have this concept of master workers. And they are kind of more the experienced workers that have done a lot of work, high performing, and they can also be leveraged to do some of the more sophisticated and complicated tasks. They have a lot of experience. And what's really cool is that we really see workers from various walks of life working on Mechanical Turk. It could be someone who is just watching football on Sunday, sitting on their couch and doing hits and earning some extra money. Or it could be workers who are perhaps bound by circumstance, who can't have access to kind of typical work, and they really love the flexibility of being able to work this way online, and they can control how much they work. This is an actual quote from one of our workers off of Reddit, and you can see right away that the type of impact that we're able to make on the workers' lives, so it's really cool to see. All right, so now we talked a little bit about the worker experience as well. So how are customers using Mechanical Turk? Well, when we first built the service, actually we launched in 2005. We really did say we wanted to provide access to human intelligence. And we left it very open-ended and general purpose intentionally because we wanted to see what type of innovations our customers will be able to unlock. And really, we actually couldn't even imagine some of the things that they were able to do. Let me show you an example.
Very simple request. I said, draw a sheep facing to the left, and I'll pay you 2 cents for your toil. So I chose sheep for a variety of reasons. First of all, selectively bred, and then kind of harvested, using them for their wool and for other things. And of course, cloning. And I created a little drawing tool and pointed them to it. And I actually recorded the process of them drawing the sheep in addition to the drawing itself. People didn't actually realize that they were being monitored. They had no idea why they were drawing a sheep. But for some reason, 10,000 people contributed their sheep. And now at thesheepmarket.com, you can see every single sheep and how it was drawn, and you can watch the animation process.
So this is definitely one of my favorite and memorable examples. And this was done in 2008 by an artist named Aaron Coplin. And sheepmarket.com is no longer available, but you can see this full video of this interview on YouTube. And what it shows is that the possibilities with Mechanical Turk are endless. So crowdsource artwork aside, what are customers using Mechanical Turk for? Well, we see them usage in 3 primary areas: microtasks, machine learning training, and human insights. And we'll go into each one of these. So microtasks. So microtasks are kind of these, you can think of these as small repetitive tasks that are simple, but uniquely requires a human to do. Examples of this could be moderation of content, so user-generated content around images, comments, categorizing of products we talked about earlier, transcribing image or audio, and as well as data collection, going and finding missing information from other websites. And customers use Mechanical Turk for microtasks, in lieu of automation or machine learning, because some customers don't have the capability or the competencies to do automation or building a machine learning model. And for other customers, even though if they are doing ML, there's some needs that are just one-off, right? So it's not at the scale where you actually, it's worth the investment to do the automation. Let's talk about a customer example. So Radiant Solutions is one of our customers. What they do is they provide high-resolution, commercial-grade satellite images of the Earth. They generate 3 million square kilometers of images every single day. And this is actually an image of a port, and they actually can essentially count the activity of the port based on the containers and things like that you see. It's really cool. So how do they use Mechanical Turk? Well, they actually do a lot of automation to have a lot of models, but at the same time, they work with customers who might be asking for something that they don't have a model for. Let's say, count the number of building rooftops that have, or urban gardens or something like that. It's something unique, they don't have it yet. So they choose to work with Mechanical Turk is because of the scale. Because there's so much image that needs to be annotated, they have access to this large scale workforce that can do this quickly. They can also ask multiple workers to complete the same task so that, again, they get the confidence level of the right answer. And they take advantage of our qualification feature so that they can target workers who are very good at some particular tasks. The next major use case is machine learning training. As you know, so machine learning is a field of artificial intelligence that really relies on statistical models to make predictions. And with that, really data does the heavy lifting. Garbage in, garbage out, the more high quality training data you have, the more effective your model will be. And this is where our customers work with us because, as it turns out, human input is needed at every stage of the machine learning training development process. For example, let's say you're trying to train a chatbot, and you want it to be able to handle customer service interactions, right? I'm calling about, I want to change a flight, or I want to return product. Before you can do anything else, you need to actually have the text utterances, like what would people type? And then once you gather that, then you need to label the data. So let's say you have lots of utterances, you need to say, well, when customers type A, they mean their intent is, I want to return something. So you need lots of labeled data. That's when you can finally start training your model. And once your model is trained, you need to actually have more human input to validate the output of the model. Is it good enough? Are you getting the right answers? And then when there's confidence is low, you can actually go out there and get additional labeled data so that you can retrain your model. And I don't know if you guys saw the announcement this morning at Andy Jassy's keynote. We announced Amazon SageMaker Ground Truth, which is a new capability of SageMaker that makes it easier for machine learning practitioners and developers to get lots of high quality training data. And Amazon Mechanical Turk is integrated right into SageMaker Ground Truth as one of the workforce options where you can have humans label your data. So I'm going to give you an example. Going back to the chatbot example, this is a real customer example. So we work with Facebook. We work in particular with the research arm that focuses on AI. And they built something called Parlay. And what Parlay does is that it's a platform that allows, make it easier for researchers to actually gather lots of text utterances. It's called chit chat, so imagine back and forth dialogue data. They standardize this so that researchers, this is actually an open source project, so the researchers can contribute to this, and this allows it, make it easier to generate lots of data that can be shared. And they chose to work with Mechanical Turk because of our large and diverse workforce, right? So you're trying to train a chatbot to understand human, text utterances. The more variation that you have in your training data, the better, because your chatbot is then able to understand a lot more. They love the flexibility in the text interface. We talked a little bit earlier about that with external questions and the fact that you can use HTML and JavaScript. I'm going to show you what that looks like in a second. And then, of course, they like the API integration and the ability to automate their processes. So here's an example of a task. So what we have here is you're trying to simulate a customer service interaction. In this case, there's something wrong with the cable modem. And what they built is, this is something that they built using Mechanical Turk and our external question capabilities, is that you actually have two unique workers working on the same task. One worker is playing the role of a customer service agent. The other worker is playing the role of a customer. And they each have kind of a little script they're following. But while they're following the script, they're trying to have a natural text-based conversation. And out of that, these dialogues goes into, becomes training data. So this is actually one of the more unique use cases of Mechanical Turk, and it's really cool. So we talked a little bit about using workers to label For a lot of these, there's a pretty objective answer. But then the next major use case is using Mechanical Turk to gather human insights. And the difference here is actually a little bit more nuanced. It's more about kind of getting some subjective inputs and also require some judgment. Here's what I mean. So how relevant is this product to the activity you're running? So what we have here is this outdoor rain jacket. It's pretty light. You can see her wearing it running, but it's not really a running jacket. So it requires you to apply some human judgment to make that decision, to rank it. So this is a good example of how using Mechanical Turk to gather human insights and opinions. So some other use cases include usability studies and testing, right? So if you have a new product and you're trying to get some feedback from users, you can do that. Rating the quality of content. So for example, you have things like auto-generated playlists based on a starting song or starting video. You want to get some feedback on how good the related songs are. So those are some common use cases. And again, customers choose to work with Mechanical Turk for this purpose because we have a very large panel of respondents, and there's flexibility in the interface. So you can do things like usability studies. So with that, I'm actually going to hand things over to Keisha right here. She's going to tell you about how her organization uses Mechanical Turk for human insights.
I'm just clicking on this one.
Yep.
Hello, everyone. As Jessica mentioned, my name is Keisha Phillips, and I am a Senior Research Director with Pearson Talent Lens. And I'll just be briefly discussing how we've used Amazon Mechanical Turk to gather human insight. And so Talent Lens is the test publishing arm of Pearson. And we are well known for providing a wide range of highly respected selection and development instruments. And right now we have over 30,000 employees in a variety of different countries. And we can see some of those here. But we are definitely now a multinational organization. And so what do? Well, we publish a wide range of highly respected assessments. And not only do we do that, but we also provide consultancy, such as job analyses, validation studies, things such as that. In addition to, we provide qualification training to our customers to administer certain personality assessments that we offer. And so just to help you get a better understanding of what we do, I'll kind of walk you through a typical client request that we might get in the office. So here, what we see is we have a client who comes to us, and they have one available position for a financial analyst. And they have dozens and dozens of people who've applied for this particular position. So this client has a limited budget for selection and recruitment, and they need to identify as clearly, fairly, and cost-effectively as possible who's the best person to fill this position. And so the client, the whole idea is they want to obtain some assessments that will allow them to gauge the knowledge, skills, and abilities that each of these applicants possess to determine who will be the best for the position. They want to make sure that the assessments are legally defensible, and they want to make sure also that they don't have to go through this process again. So it's very important that they are able to identify assessments that can actually assess these candidates on what's required for the job. So we would take into account the information that they provide us about the job. We do our background research on it, and then we go back to the customer and we propose certain solutions to them to assess these required knowledge, skills, and abilities for the targeted position that we're discussing. And so for this financial analyst position, once we do the background research, one of the first things we found is that critical thinking was very important for the job. So by identifying that, we would recommend to the client our Watson-Glaser critical thinking appraisal to be able to assess candidates on this. And here we see a sample question from this questionnaire that assesses their ability to make inferences. And likewise, numerical reasoning was found to be important for this position of a financial analyst. So we would recommend to the client our numerical sequences assessment in order to assess this. And we have a sample question here as well, showing what that test would look like. And then one of the final key requirements for the position was attention to detail. So we would recommend to the client our workplace personality inventory in order to assess attention to detail amongst some other work styles. And this is one example of one of the items from that questionnaire. And so just to help you understand what it means when we talk about data collection, in our day-to-day, we have to collect data on all of our assessments in order to finalize them. We have to test the difficulty of the items. We have to identify norm groups, because when we provide assessment results to our customers, we're providing them with a percentile. And that percentile will show them how this candidate performed in relation to others in that particular group for which they were tested. So in order to be able to provide that, we have to have data on how people in that group performed. And so here you'll see, so what we would do, we would create a hit on Amazon Mechanical Turk, and the M-Turkers would fill out our workplace personality inventory, and then we would analyze the data. And those are the 16 work styles below that compose that scale. And based on the data that we receive, we create these 3 norm groups. And then this just shows you how people tend to perform on the 16 work styles for this particular scale. And so that's just the type of information that we would need in order to finalize our assessments and create these norm groups. And we make recommendations to our clients on which norm group that they would choose if we don't have one directly related to the position that they're testing for. And so in the day-to-day data collection, which is a huge part of what we do, we've been faced with many, many challenges that we've had to overcome. And the first of which is our ability to collect data in a timely and efficient manner. And the reason we've had a problem with this is because in the past, we've utilized our current clients and universities to provide access to their university students in order to fill out our questionnaires. But as you can imagine, this oftentimes can become a very time-consuming, cumbersome process, because you have to coordinate with the different universities, coordinate with the organizations. You have to identify points of contact. If you're using multiple locations at each location, many times you have to give them 2 weeks or a month in order to get the results back. So it can critically delay our ability to collect data for our assessments. And likewise, we've also had problems with obtaining adequate sample size, in addition to obtaining diversity within our samples with respect to demographics and geography. And this is especially true because many of our assessments are global, so we need to collect data in multiple countries, which becomes very difficult when you're using universities or current customers. And then because we collect so much data, the cost has also been an issue for us. So we've also been seeking to find ways to minimize the cost of our data collection. And so we've definitely been faced with trying to find a solution to this problem. And the implementation of a reputable and credible crowdsourcing site has been very critical for us. And we've used, over the past few years, many different crowdsourcing sites, and Mechanical Turk has definitely proven to be a top resource for us. We found that it has worked very well, and we've been able to collect data in multiple countries, such as in the US, in India, and Latin America very quickly. We've also been able to look at the quality of the data and see if this data that we're getting from Mechanical Turk represents the real world. And we'll talk about that a little later, but we've also been found that the M-Turk data does represent real world samples, which is important for us. And so M-Turk has had a very, very huge impact on our organization with respect to our ability to release our products. And so specifically, it usually would take us about 6 months to get one product out the door once we start data collection. Since we've implemented M-Turk, we've actually been able to release this year alone 3 products in 6 months, which has been huge for us. We've gotten to the point where data collection that in the past has taken weeks and months, we've been able to collect that data in hours and days. So it's been tremendous for us. And we've also been able to cut our costs based on what we were paying before by about 4 times less than what we were paying previously. So we've been very, very happy with MTurk. And so the use of quality control items is one thing that we've been able to utilize to make sure that we can increase the quality of the data that comes out of MTurk. And so quality control items, these are items that we put inside of our assessments that have very obvious answers to them. And we use that to sift out participants who might just be rushing through the assessment to get the incentive. So these items, an example would be, I have never brushed my teeth. And you're rating that item on an strongly agree to strongly disagree. And so clearly there should be an obvious response to that. And any item that we implement, we make sure that we put it on the same scale as the other items, so it's not obvious that it's one of the quality control items. So if all the other items are on strongly agree to disagree, that's the type of item we would put into the assessment. And what we do is, when we post the hit, we let the MTurkers know that we will have quality control items embedded within the assessment, and if you fail to respond appropriately to any of those items, you will be flagged and you will not be paid for the hit. I think, and this also has worked to help participants, understand that just because we can't see you, you're behind the computer screen, this is important, and we hope that you do take it seriously. And so I would like to share with you just some of the kind of research findings that we've had and best practices that we've utilized from kind of trial and error over the years of using MTurk. Because one of the main criticisms that you will hear of crowdsourcing data is that you can't really trust the quality of the data. You don't really know what you're getting. And as we kind of just talked about, using quality control items is one way to increase the quality of your data. You can utilize it to remove those cases of individuals that have been flagged and don't include them in your final analyses. We found, Jessica previously talked about the masters and the non-masters, and so I did a study where I compared the quality of the data for the master group versus the non-master group. And we found that 91% of the data in the master group was of high quality, and 82% of the data in the non-master group was of high quality. And those are really pretty good numbers. And a reason to make a key distinction is if you do choose to use the master workers, you pay more for that. So you want to have confidence that you're getting better data if you're paying more for those master workers. And this is what our research has shown, that they actually are of higher quality. We also found that the higher quality group actually spent significantly more time in the assessments. It was about an average of 7 minutes, which suggests that these people are actually spending more time reading the items and hopefully not just sifting through and not paying attention to get the incentive at the end of the assessment. And one of the other big questions that you have, and I kind of briefly touched on this before, is when you're using crowdsourcing data, are those people similar to the people that you get in a real world setting? That's a huge question. And so we did research in order to answer that question. And what we found in our research is that those MTurkers were very similar. There were no significant differences with respect to age, gender, race, and educational attainment in an employment context or a selection and development context for job selection, if they're getting promotions or if they're seeking a new position. So the fact that they were the same as the real workers, no significant difference, that was very huge for us. So when looking at the research that we've done, we are very proud to be users of Amazon Mechanical Turk, and it's definitely boosted our confidence in using MTurk as a crowdsourcing tool. And so I'll turn it back over to Jessica.
Yeah, thank you so much, Keisha. It's always great to, one, learn about a real-life customer use case, and also to hear firsthand about how our customers are using this and how it's benefiting their organization. So next, I'm going to turn things over to Jeffrey. He's going to tell you about how his company, Signal Labs, is using Mechanical Turk for machine learning training.
Thanks, Jessica. My name is Jeffrey Fenchel, and I'm a senior software engineer at Signal Labs. I'm going to walk through essentially how Mechanical Turk functions as the backbone for machine learning at Signal. But first off, let's start with some perspective. What do we do at Signal Labs? Our mission is to provide our customers with real-time insights across the media spectrum so that they can make more informed decisions. Today, we provide a platform for our customers to answer questions like, what is their share of voice against their competitors after a major product launch? Or to view the health of their brand in real time, or even to stop a crisis early through the identification of a trending story. What we're really here to do is to support these customers, these organizations, whether it's communications, PR, marketing, executive teams, investor relations, throughout their entire workflow, from understanding of what's going on to taking action. So we can start to understand this workflow and break it down into analytics that we care about solving. The first type of analytic that we care about here is descriptive analytics, essentially where we try to understand what happened in the past and what's happening right now. This is where we solve questions like, how many mentions did my brand receive in the month of October? Or even, what media outlets captured my brand? From there, we move on to diagnostic analytics, where we try to understand why what happened took place the way it did. And this is where we can start to answer questions like, what was the sentiment across the earned media for my brand? Or even, what events drove the conversation during this time frame? And as you noticed here, we're already past the realm of where traditional analytics can solve these questions. And we're into where we need to rely on machine learning techniques to answer these questions, which is why machine learning is so important to us at Signal Labs. But we can go one step further and talk about predictive analytics and ask questions like, is this piece of content going to go viral? Or if I don't intervene, how long will this story dominate the conversation for my brand? And even further than that, we can talk about prescriptive analytics, trying to make recommendations about what people should do to help impact the conversation around their brand. We can answer questions like, how should I formulate my content to best leverage the current events in order to maximize my message impact? So at Signal Labs, we certainly have a lot of really interesting questions that we can solve. But one of the questions we looked at early on was sentiment analysis. We had an off-the-shelf solution in originally, and we got some feedback from our customers. First, they told us that sentiment was really important to understanding their brand health. And secondly, they let us know that the solution that we had in place wasn't sufficient for what they needed. So we decided to take a look at the data and try to understand what was going on that made our problem so difficult compared to traditional sentiment analysis. And we found that some of the time, the answer was pretty obvious, like in this case, where we've got a great group of people making the world a better place. But other times, it gets a little bit more complicated. There's this notion of sentiment that is tied to emotion. So if you have a negative emotion, you have a negative sentiment. But there's also another perspective we can take here, where we can ask ourselves, well, what does this content say about John McCain as a person? And lastly, we have a lot of news content in our system that tries to be a generic statement of facts and does not try to present a biased view of the information. And even with this content, we can find that it does have an impact on how we think about companies. For example, what does this make us think about Lehman Brothers? So we wanted to do a rebuild of our sentiment solution, and we identified 3 key pillars here that we wanted to take advantage of in order to do a better solution than what we had originally. First off, we wanted to redefine what we thought sentiment was. We decided to pick this idea of polarity for reputation, where we focus on how a particular statement impacts the image of a brand or company going forward. So in the case about John McCain, we would actually say that's positive because it gives us a good view on who John McCain was as a person. Secondly, we have a lot of data streams in our system for a lot of different customers, thousands of data streams. And some of these data streams are a lot more noisy than others. So if we took the approach of randomly sampling across these data streams, we could come up with an awesome sentiment classifier that would do really well at classifying the most noisy streams in our system. However, if we turned around and looked at the kind of quieter streams in our system, which customers still care about, our measurements would mean that we wouldn't have to have a good sentiment classifier for these minority data streams. So what we did is we decided to adopt the approach of stratified sampling to leverage our knowledge of the different data streams in our system. So we equally sampled both the noisy and the quiet data streams. So we have a good classifier at the end of the day for both types of streams. And lastly, we wanted to do something about trust and transparency. Machine learning is great, and that allows us to answer questions that traditional analytics could not. But it's not perfect, and we wanted to communicate that to our customers. So next to the sentiment charts that we provide. We wanted to also provide them with metrics around how good these sentiment metrics are for them, whether that's 70, 80, or 90% accurate. So I work on a team of 5 people. We're really small. Traditional machine learning techniques they require a lot of labeled data to get off the ground. So on a team of 5, there's no way we can even approach these by ourselves without the help of something like Mechanical Turk. Mechanical Turk here provides us a scalable solution to leverage hundreds of thousands of people in the cloud in order to build this initial data set. Additionally, it allows us to leverage them in an ongoing fashion. So my team can move on and solve more interesting problems as we continue to have this stream of labeled data come into our system. For us, having an API there was really important. It's what allows us to do the initial work up front to build out this infrastructure and then walk away and solve those other interesting problems in our platform. And flexibility is also hugely important here. As we move on to other more difficult problems, our worker interfaces get more complex in order to support them in their workflow. And having kind of the flexibility here in order to do those complex annotations is really important to us. And lastly, it's low cost, something my startup can afford. So I'm going to essentially walk through 3 key aspects here. First, we're going to start at our labeling pipeline, how we get data from our platform up to the crowd and get labels. Secondly, we're going to look at our model lifecycle, how we leverage these labels to do inference inside of a real-time data pipeline. And lastly, we're going to look at what's next for Signal Labs and how some of our tasks have become more complex and how Mechanical Turk is still able to support that. So first off, this is kind of what our continuous labeling pipeline looks like at Signal Labs. We start with a process that's hosted in Elastic Container Service on Amazon. And it wakes up every day and samples our Elasticsearch data store, which contains news, tweets, Reddit, social media, a lot of other sources, and does the stratified sampling technique that we wanted to get at. It takes these documents, these tweets, and transforms them into questions that our workforce can then understand and answer. We publish these to Mechanical Turk, where we ask that 5 people answer every question that we have. From here, we have another process in Elastic Container Service that wakes up periodically and finds all the questions that are complete on Mechanical Turk. It looks at these answers and tries to understand what our worker quality and worker biases are and finds these best fit answers to the questions that we've published. It then pushes these answers to our Elasticsearch data store so we can have that transparency with our customers going forward about how accurate their sentiment is, as well as to our S3 bucket so we can leverage these labels to continuously make our model better. So throughout this whole process, labeled data quality is really important to us. Essentially, our model is going to be limited in quality to the quality of our labeled data. So during this whole process, sources of disagreement were hugely important to us. When we talk about disagreement, there's two kind of aspects here. There's disagreement between Signal and the crowd, and there's also disagreement within the crowd itself. So kind of the first major aspect here that we identified was task ambiguity. Sometimes what we found is that what we had in our heads at Signal Labs wasn't really effectively transferred to the crowd, and we iterated and worked with our workers to help improve our instructions going forward. Additionally, we found that sometimes there was ambiguities between our instructions and the data that we provided. So we did things like add additional answers. For example, we added the case to have multiple polarities in the case where there's both extreme positive and negative sentiments expressed in the same statement. The next kind of aspect that we looked at was worker perspective. In sentiment, worker perspective sometimes causes disagreement. We have a lot of content in our system that's fairly neutral in respect to news. And even though it doesn't express a polarity directly in the text, it does give us a sense of feeling as a person reading it. And we rely on our worker humanity to kind of come to the sense of feeling about what the polarity is. And in doing this, sometimes it's really obvious, but sometimes there are issues that are pretty polarizing, especially in the political spectrum. So when we're coming up with one sentiment value for a given story, this can cause disagreement, and it's something we understand. Lastly, worker quality is important to us. Not everyone spends as much time reading through our questions and giving us thoughtful answers as other people. So this is something we have to be aware of and filter out and take into account when we weigh our individual responses to come up with that best fit solution. Throughout this whole process, we really wanted to understand our workers and see how we could help improve the situation to help them give better results to us. So since we're publishing daily batches, we wanted to look at, do these workers actually come back, and do we have a solid following here? And we found that after the first 50 days, roughly 50% of our workers had come back more than 10 times. And it's even gotten better since we've continued this for almost 8 months now. And essentially, what this means is we can start investing in our workers to help make them better. So on a weekly basis, we provide them individualized feedback saying, here's what you answered for us, and here's what our best fit answers were. Now, this is in no way perfect, but directionally it helps a lot. If they see they're missing a lot of content, they kind of get a feeling for, oh, that's what you actually wanted, and that's what you meant by those instructions. It especially helps bring new people on into our workforce as we move forward. So we have all these labels sitting on S3 now, and we need to leverage them to build a model and put that model into our production data pipeline so we can stream content through and assign sentiment values to it. For this, we leveraged Amazon SageMaker. Essentially, we wrote a Lambda that triggers every day to start a new SageMaker job. And this SageMaker job goes out and pulls our full repository of labels from S3, wraps that up, and runs a training algorithm to build this sentiment neural network, and then publishes that model to S3 so we can pick it up later in the situation. It also handles all the infrastructure for us, so we don't have to worry about spinning up and turning off hardware. The second step of this is the deployment process. We use canary deployments to make sure that we safely introduce new models into our system. Every day we introduce the new model. It has a 5% variant, meaning 5% of the traffic gets introduced to the new model. When we've determined that the model is working successfully, we promote that variant to take 100% of the traffic going forward. So with all this whole process, measuring and understanding the quality of our systems at Signal Labs is really important to us. We measured both the accuracy of the new solution that we built out and the accuracy of the old solution that we built out. And we found that we had a 25 to 30% accuracy improvement. Now, this is by no means a fair measurement, because we've done things like change the problem we're solving in our redefinition and change the data set that we're evaluating against. However, for us, what this means is we're 25 to 30% closer to customer expectations, which is huge for us. We've also included a lot of metrics around understanding worker quality, so we can kind of get a sense to make sure that our workers are continuing to give us the same quality that we had at the initial start of this experiment. So sentiment's pretty boring, and we've got a lot of other questions to solve in our platform. We've started to move on to solve some of these other problems, like automated account detection and named entity recognition. And it's really been great to see how Mechanical Turk can still support us as our user interfaces for labeling get more complicated in order to properly support our workforce. We leveraged React to kind of build out modular UIs for this whole process. And with that, we've had to start hosting our own questions as well. And we've leveraged the other Amazon services inside of the environment to host these questions. We leverage Amazon S3 and CloudFront in order to host our web elements for both the tasks and our qualification tests. And on the other side of the qualification test, we have an API that's working with Amazon API Gateway, as well as Amazon Lambda, in order to judge the qualification test and apply qualifications to those workers that successfully pass our test. It's really been great to see how Mechanical Turk can kind of help make my team of 5 still effective at solving all these problems in our system. And it's been great to have that support going forward so we can be really effective at solving a massive amount of problems for my small company. But thank you so much, Jessica.
Thank you, Jeffrey. That was great. I love how you're using all the different AWS services to achieve your solution. And here are just a few of the customers who are using Mechanical Turk today for the use case that we talked about, which is human insights, machine learning, as well as microtasks. So now that you have heard about how customers are using Mechanical Turk and how it's benefiting their organization, and you're like, okay, maybe I have a use case that I can try out using Mechanical Turk. What are some of the things that you should keep in mind before getting started? And these are some of the things that we either learned through experience by talking to our workers as well as our requester customers, or just saw that firsthand being customers ourselves. So the first best practice is taking the problem and breaking it into simple, discrete tasks. For example, you're looking at an image. This is a simple categorization task, and you're saying, is there a dog in this image, yes or no? And the worker just has to do one thing. And again, it's also using some very basic foundational user experience design best practices, right? Is to have like the action on the right-hand side, have a very clear call to action. Here's an example of what not to do. So this is saying, hey, find and label all the animals and the people and the image and identify and classify the images. Now, this is certainly possible, And as mentioned earlier, some workers who are really have attention to detail, they will take the time to do each of the things you ask for. However, keeping in mind that if you're trying to get the best quality answers, having the task be simple, directed, and self-contained actually ends up getting you the better results. So in this case, if you are trying to label multiple classes of things, you might want to do 2 passes over the same image. One pass where you're just asking workers to perhaps draw a box around the things that you're interested in, and then a second pass to have them label the items in the image. Work on the task yourself with real data. I think Jeff mentioned this a little bit earlier too, is task ambiguity. So you're designing your task in your head and you're thinking, yeah, the instructions are pretty clear. I want to have you give me the sentiment of this tweet. But then you start going through your real data, you're like, oh my goodness, actually it's not as clear as I thought it would be. Perhaps I need to add more information about what I actually want from workers. And you really only get that by doing the task yourself with your real data. And also, leverage your teammates, right? Because again, they might not have as much context as you. So when they work through those tasks, they might come up to you for questions and say, hey, like, what should I choose here, right? So you might want to add more detail, say, all right, is there a primary emotion, or in the case of the reputation aspect of it, oh, actually, I want sentiment towards the reputation of the entity or the organization it's talking about. But it's really important to try it out with the real data. So, we talk a lot about Mechanical Turk being an API. You can automate it. It's API access to human intelligence. But it's too easy to forget that actually these workers are humans. There's humans at the other end of the keyboard doing these tasks. And so, therefore, it's important to remember, give them clear instructions. Show them, don't tell them. So, for example, if you're doing image classification and you're looking for, classifying different types of birds, show them pictures of different types of birds, right? You're not going to try to describe them in words. Just make it easier for them to understand what you're looking for. Another one is pay them for their efforts. So many workers are here. They're not just incentivized by the reward that you pay, but that's certainly a big part of it. And so again, certain workers, they have their good days and bad days. And I think what's important is that they feel like if they have put in effort, that they should be rewarded for that effort. But feedback, of course, is also really important. Listen to their feedback. So it's actually a little bit surprising that once you start publishing tasks that you'll start getting feedback and emails from your workers. For example, they might say like, hey, none of the categories you gave me fit. Like, what should I do in this situation? Perhaps you want to add a, none of the above or something like that. Many workers have been on the marketplace for a lot of years, and they've seen lots of different types of tasks. They're kind of, giving you a heads up and say, hey, look, I need more instructions. So listening to your feedback, you might actually discover something about your data that you don't even know about. Help them be efficient. We talked a little bit about kind of the UX design aspect of it, right? So the way it works is that you price per task of how much you want to pay a worker. So let's say you price a task at 5 cents. Well, if it takes a worker 1 minute versus 3 minutes, that's a huge difference. So some of the best practices are things like, making the call to action very easy to find, as well as things like keyboard shortcuts. Those are things that will, especially when workers are churning through a bunch of tasks, it makes it a lot more efficient. You don't have to pay more, but they will like you a lot better. At the end of the day, you need to earn their trust because some workers, they don't know you either, right? You're also on the other end of the keyboard and they don't know who you are. So they're not sure, are you going to pay them? Are you going to reject their work? Are you trying to do something weird? So again, they might be looking for responses from you. They participate pretty heavily on online forums and channels and things like that. So they want to be treated like humans, right? So you want to also get back to them and give them that responsiveness that you yourself would expect. So those are just a few things. And again, our team, we talk to our customers all the time, and we've been doing this for a while. And some of these lessons were pretty, we learned the hard way, but hopefully you don't have to do that. And now that you have a few tips for getting started, there's a lot more information on our website at www.mturk.com. And also, if you want to get your hands dirty and get hands-on with how to do this, we actually have a workshop this afternoon to do data collection via Mechanical Turk. I think if you have the time to join, that's going to be a lot of fun. So thank you again for coming to this session. Jeff and Keisha and I will be here after the session to answer any questions that you have. And don't forget to complete the survey. Thank you so much.